Hello friends, let us now learn some important points about the types of generators. So before we go into types of generators, first we will see the three-phase alternating generators. So three-phase generators are important to produce constant potential difference across the X-ray tube. So if you see, the problem that you have seen in the last lecture is that this is the graph which is drawn by plotting X-ray tube voltage and X-ray intensity which is produced. X-ray tube voltage will start from 0, it will increase to 0, and then it will come down to 0. Okay, and again it will start from 0, it will increase to maximum and it will come down to 0. So it starts from 0, increase to maximum and comes down to 0. Again it starts from 0, increase to maximum and then comes down to 0. See, this coming from 0 going to maximum and then coming back to 0, this is like, so the X-rays which are produced also will start from least or 0 or least amount of X-rays. They will reach maximum, that is maximum intensity of X-rays, and then intensity of X-ray decreases. So this, in the middle portion you will have less intensity of X-rays, right? So this less intensities of X-rays are not desirable for diagnostic radiology. What we want is the constant amount of, at least we should have less fluctuations in the intensity of X-rays. So we have to decrease this. The way of decreasing this was found with the help of the three-phase generators. So in three-phase generators, these three-phase generators produce almost constant potential difference. This will produce not completely but almost constant potential difference across the X-ray tube. It will produce almost constant difference across the X-ray tube. So just see, there are three phases. So the commercial power supply is usually produced and delivered by three phases of alternating current generators. So the three phases are phase 1, phase 2 and phase 3. So in phase 1, if you see, this is the normal alternating current which is produced. See, this is in 0 phase. That means it starts from 0, goes to 90 and then comes back to 180. And then from 180 to 270, 270 to 360. This is how it goes. Okay, so this is the phase 0. So phase 1, in phase 1, so this is called as 0. This is 90, 120, 180, then 240, 270 and finally 360. Okay, then the next type is phase 2. In phase 2 lags 120 degrees behind phase 1. That means it starts when phase 1 is at 90 degrees. Okay, when phase 1 is in 90 degrees, that is the point where phase 2 starts. See, I will draw this in a better understanding way so that we will see. So this is the phase 1. Okay, this phase 1 is from 0. It will start like this. Okay, now this is the point where phase 2. So here the phase 2 lags 120 degrees behind phase 1. Meaning that this is phase 1. This phase 2 will start 120 degrees behind phase 1. So this is 120 degrees, right? This is 90, 120, 180, 270, 360, right? It is 120 degrees behind phase 1. So this is 120 degrees. So the phase 2 will start 120 degrees behind phase 1. So this is when the phase 2 starts. Okay, something like this. Okay. Then if you see the phase 3 will lag 120 degrees behind phase 2. So this is phase 2 0. Now again phase 2 120 will be here. So this will start at phase 2 120 degrees. Okay. I think we have understood phase 1, phase 2, phase 3. See, all these three I will draw this one in one graph so that we will understand even better. Okay. So this is phase 1 which starts from 0. Okay. So phase 1. This is phase 1 which starts from 0, 90, this is 120. Okay, when the phase 1 is this one. So phase 2 starts 120 lags, phase 2 lags 120 degrees behind phase 1. So when this is 120 degrees, here the phase 2 will start. So this is phase 2, right? So phase 2 is starting at 120 degrees behind phase 1. So this is phase 2. Which is starting like this. Okay, it is something like this. Now we have phase 3. Phase 3 will start 120 degrees behind phase 3, phase 2 will lag 120 degrees from behind phase 2. So this is phase 2. The 120 degrees of phase 2 is this. So this is when the phase 3 will start. Okay, so this is phase 3. Okay, so I think you have understood. So if you see, this is the positive part, this is the negative part. By the time we have completed one current, this is the least part, right? This is the least size. This is the high voltage part, high voltage. This is also a better voltage, but in between here there is very less voltage, right? Also almost in between. So in between there is one more. Second phase will produce maximum current. Again here also, here from second phase, this is the least part. At this part, the third phase will produce its maximum voltage. So in this way, what is happening is that this low voltage part is decreased, and there is almost not complete constant voltage, but there is almost constant voltage of potential difference is seen in this 3-phase alternating generators. So 3-phase generators are complex. So we will see, before we go into the 3-phase generators, the 3-phase generators are again of 3 types. So before we go into this 3 types of 3-phase generators, we should learn about the 3-phase transformers. Generally we know, we have already dealt in the previous class about 2-phase transformers, where the first primary winding is so transformer is a core with multiple sheets, rectangular sheets with laminated core, and then a coil is wound and is connected to the electricity on one end, which is called as primary coil, and the other coil is wound around this rectangular core on the opposite end, and it is connected to the voltmeter, right? Changes in electricity in the primary coil induces magnetic field, which in turn induces current in the secondary coil. So that is the main gist. Now there are 3-phase transformers. In 3-phase transformers, there are 3 sets of primary and secondary windings. So these 3 sets of primary and secondary windings are given as 2 types. One, we have delta type of configuration, and we have Y or star type of configuration. So let us see both of them. So 3-phase transformers are given in 2 types. One, we have delta type of configuration, and the other is Y or star type of configuration. So first, in delta type of configuration, this is the delta type of configuration where the coils are arranged in triangular shape, whereas in Y type of configuration they are arranged in this way, right? Now these 3 are connected to the electrical potential. See, in this can act as primary and this can as secondary. These both can be, see, this delta and Y, these both can be kept side by side, and this can act as primary, this can act as secondary, this can act as primary, this can act as secondary, this can act as primary, this can act as secondary. So in this way we can alternate it. So what about the output voltage? Output voltage of this delta and Y. So you have to remember that output voltage of these 2 is same value, same maximum value, but it is 30 degree shift between the 2 values. So that means if this is the delta output voltage, okay, then so I'm drawing like this only so that it becomes easier. Okay, if this is the delta output voltage, then 30 degrees, not this shift is just 30 degrees. This will be the, and here it will start. So this will be the Y's voltage. So it's something like that. So there is out of shift of 30 degrees is seen between the delta and Y output voltage. Okay. So let us see the 3-phase generators. 3-phase generators are divided into 3 types. One, we have 6 pulse 6 rectifier. Second, we have 6 pulse 12 rectifier. Third, we have 12 pulse type of generators. So first we will see 6 pulse 6 rectifier generators. So this design of 6 pulse and 6 rectifier generator consists of a delta wound primary winding and a Y wound secondary winding. The output of this wave wind secondary winding is connected to 6 solid state rectifiers. The 6 solid state rectifiers are actually 3 full wave bridges which are tied together. These are 3 full wave bridges which are tied together. So we have 3 phase output and a rectifier arrangement is given. So what happens in this we will see. So when the current flows from P to Q, we are just concerned with one bridge, okay, I'm just going to see about this one, okay. When current flows from P to Q, then this will cause increase in current. Whenever there is increase in electrons, this causes increased magnetic field. This increased magnetic field will induce current in between A to B, okay. We are just thinking this has one circuit, and we take A to B has secondary coil, and from A to B there is induction of current, and think that A is negative potential and B is positive potential. When A is negative potential, the electrons from A will travel in this way. They will go like this, and from here there is 2 ways, one through R4 and the other to R3. R4 there is P to N, the electrons cannot flow, so the electrons will flow from N to P in R3. So from R3 the electrons will flow down, okay. The electrons here, this is R5, right? The electrons cannot flow from P to N in R5, so the electrons will flow down and it will reach the cathode. Now in the cathode there is filament is heated and electrons are produced, and they bombard the target anode. From the target the X-rays are produced. Again from the target anode the electrons will move like this. In R6 they have these ways, but still they have to reach B target, so they will start reaching the B target. They will go like this, they will go like this, and they will reach the B target, okay. So this is the way that the electrons will flow in this circuit. This is in one way, okay. So what actually happens is, so this is the electricity, okay. We have 3 phases also, right? This is the first phase, okay. In first phase there is electricity which is generated, okay. Now this is the second one. In second part, the A is, so there is decrease in electric current. When there is decrease in electric current, there is decrease in magnetic field induced. This induced magnetic field decreases, and this will cause positive charge on A and negative charge in B. There is reversal of charges. So this will be negative. So from negative the electrons will pass from R1, because this is negative, from N to P the electrons can flow. So the electrons will flow like this. Now the electrons will again flow. They won't flow in the they cannot flow from R3 through R3 from P to N, so the electrons cannot flow like this. The electrons cannot flow in R5 also, so they will reach the cathode. So from cathode the filament gets heated and electrons are produced, electrons are emitted, and they travel towards the anode. They hit the target anode, and from here the electrons will travel like this, and from here the electrons will travel like this. They can go in either ways, but this is the ideal way to reach A. So it reaches to A, okay. So this will result in production of X-rays, okay. This production of X-rays is from A to B. So in this direction this is the production of X-rays, okay. So in both these cycles the X-rays are produced, okay. Similarly P and R acts as the primary one, and so this one B and C acts as secondary coil. P and R acts as primary coil, B and C acts as secondary coil. These P and R will be 120 degrees outlet. So this is 1, this is 2, this is 3, okay, in the previous generators. So this is 120 degrees out of phase of P and Q. So this is the first P and Q, so this is out of phase. So 120 degrees, so this will start like this, okay. Right. So because this is 120 degrees out of phase, so here there is production of this will be like this, okay. Okay, fine. Now so when both of these, when similar way which we have did previously, there is production of X-rays on both the sides. When this is the second phase, when this is R, this is P also, there is production of current, okay. That is what we have seen in this too, Okay, now again we take the third phase. If you see, the third phase is 120 degrees out of phase of the second phase. So 120 degrees is, this is 90, this is 120 degrees. So third one will be 120 degrees out of phase of second one. So it will be something like this. So from here again there is starting of one more. It will be like this. So there is starting of one more. So I'll draw this again so that it becomes easier. It didn't come properly. So this is the first. This is the first one, and from here this is the second one. Okay, now this starts from 120 degrees of this. So this is from here it has started. It is something like this. Okay, then this has started from here, right? So in this way, if you see, if I remove this part and only the upper part if I draw, there is 1, 2, 3, 4, 5, 6. By the time of one complete cycle, there are almost 6 pulses are seen. So this is called as 6 pulse, and this is called as 6 pulse, and there are 6 rectifiers. So this is 6 pulse and 6 rectifier circuit. Then we have, so this is the one. So I have already, whatever I have, see, this is the first one is this one. Okay, the second one is 120 degrees out of phase, that is it starts from here. This is the second one, and the third one is 120 degrees out of phase of second one. This is third one. So all these will overlap with each other and it will result in 6 pulses like this. So this is 6 pulses. So here 6 pulse, 6 rectifier circuit. Okay, so one cycle has 1 by 60 seconds or 1 hertz. Okay, so now we should learn what is ripple factor. So ripple factor is variation in voltage across the tube, which is expressed as percentage of maximum value. Ripple factor is the variation in voltage across the tube, which is expressed as percentage of maximum value. This is called as ripple factor, meaning that this is the variation of voltage. In single phase generator, in single phase X-ray circuit, you will see that in single phase full rectified, you will see 2 voltages, and the variation of voltage is like there is 0, 0 to maximum, then again 0, 0 to maximum, and again 0. So this is like, this variation from 0 to maximum is ripple factor. So the ripple factor is 100%. There is variation is 100%. Whereas if you see in a 6, this is 3-phase circuit, that is 6 pulse. In 6 pulse rectifier, see the 100 kilo voltage fluctuates between 86.5 and 100. Meaning that the ripple factor is 13.5% for 3-phase 6 pulse rectifier. We have the ripple factor of 13.5, that is there is fluctuation of only 13.5%. Here the fluctuation is almost 100%, here the variation is only 13.5%. Similarly, if we use a 12 pulse rectifier, this has a theoretical ripple factor of around 3.5. So when 3-phase generators are used, then the ripple factor, so this is the normal ripple factor. But sometimes what happens is, when we use a 3 pulse rectifier, 3-phase generator, so what happens is, in reality, so this is the theoretical ripple factor, true, but when 3-phase generator is used, so the ripple factor is more than the theoretical ripple factor. Okay, this ripple factor when a 3-phase generator is used is called as load ripple factor. This load ripple factor is the actual ripple factor, and it will be more than the theoretical ripple factor, and this load ripple factor is around 5% for this 12 pulse system. 12 pulse rectifier, the load ripple factor is around 5%. Okay, then the next type of rectifier is 6 pulse 12 6 pulse 12 rectifier circuit. Okay, in this 6 pulse 12 rectifier circuit, we can see that there is a delta winding which is a primary winding which is a delta winding, and we have two secondary windings which are Y winding. Okay, so Y winding. So Y winding, there are two secondary windings are present, and this is also a 6 pulse rectifier only, and this here the potential is fixed to the ground. This is one advantage over the 6 pulse rectifier, 6 pulse 6 rectifiers, because there is no ground potential arranged. Here there is ground potential is attached. So because because this potential is fixed to ground, the circuit is fixed to ground, this will allow a higher voltage, that is 150 kilovolts generator with a voltage fluctuation from -75 to +75 can be applied to this 6 pulse 12 rectifier. So what is happening is that, see, it's the same thing. This is primary, this is given as secondary first. So this is in phase. It is similar to the previous one. See, this is the first pulse, so this will result in 2 X-rays. Okay, okay, then we have the second one which is 120 degrees out of phase. So it will start like this, it will be like this. So it is 120 degrees out of phase, so it is almost 120 degrees, so it will be something like this. Okay, okay, then we have the third, this is the first one, this is the second one. If you take, this will be the second one, this is the third one if you take. Okay, second, and this is third, this is one, this is second, this is third. Okay, so this is the third circuit. From third circuit, third phase is 120 degrees out of phase of second phase, so it will be something like this. Okay, so now this will result in again one more X-ray which is like this. Okay, so what has it what has it done? It has again done a 6 pulse. Only 6 pulses are produced. Even if we see this circuit also, this also produces the same way. Again this will repeat. Even if we take this as prime first, this as second, there is no difference. It will overlap with each other. So as a result, this is 6 pulse 12 rectifier circuit only, and the ripple factor of this is also 13.5. Okay, the next important thing is 12 pulse rectifier. So what is this 12 pulse rectifier? Okay, in this 12 pulse rectifier, this is almost similar to the 6 pulse rectifier. See, here also there are 12 rectifiers. There is one primary circuit which is delta, whereas we have secondary circuits, one is Y and one is delta. That is the difference. Here the two secondary circuits are Y only, whereas here the one primary circuit is Y, the other, sorry, one primary circuit is delta. In the secondary circuit, one secondary circuit is Y and the other secondary circuit is delta. That is the only difference. That is the reason why we get 12 pulses here rather than 6 pulses in the previous example. That is because, if you remember, in the beginning of the class I have said that the Y and the delta are out of phase by 30 degrees. Okay, Y and delta. So delta will lag the Y by 30 degrees. So this lagging will fill the ripple between the 6 pulses. So I will show you. So this we will draw a little bigger, so that broader actually. One. Okay, so this is the X-ray. Okay, this is the wave. Okay, this is first phase. So this is the first one. So I will draw the one which is the X-ray are produced, and this is the X-ray produced in the first primary cycle, the first positive voltage, and in the negative voltage one more X-ray is produced like this. Okay, let me draw below. So X-ray is produced like this one, and this is the second X-ray which is produced. Okay, in negative circuit, this is the negative voltage, this is the X-ray produced in negative voltage. Now from here, this is the secondary one, the second circuit, this is second phase. This I am taking as second phase, this part. Okay, so in second phase will lag almost 120 degrees from the primary phase. So this will be something like this. Okay, So if I'll fill this part, this side. Okay, so this is the secondary part, second phase. So in second phase, there it starts from 120 degrees. Here also there is X-rays are produced from positive and also in negative. So X-rays are produced something in positive and in negative X-rays are produced. Okay, okay, this is the, sorry, like this, no, it will come like this. Okay, this is the second phase. Now this is third phase again. So this part here, this is third phase. Here also X-rays are produced in both positive and negative cycles. This third phase is 120 degrees away from the second, lags 120 degrees. It lags 120 degrees from the second phase. So this is the third phase. Okay, so this is the, okay, just for understanding. Okay, this is the third phase. Now what happens is, in the third phase again, this is 120 degrees. So this will fill the factor between the first and second. So it will be like this. Okay, fine. So okay, we have got this one. So we have 1, 2, 3, 4, 5, and this is the sixth one. Okay, we have 6. Okay, this is the ending, this is the end. Okay, so this is the primary wave. Okay, so we have 1, 2, 3, 4, 5, 6. Okay, this 6 is for this Y circuit, right? Now similarly we have to do for star circuit. And if you remember, the output from star circuit is again 30 degrees difference from 30 degrees, it lags 30 degrees from Y. The delta, this delta will lag 30 degrees from Y. So this is the Y output factor. So the first one, this is the first one. So I'll take this as first one. Okay, this first one will lag 30 degrees from Y, right? So this is 0, this is 90, this is 45, 30 degrees will be here. So the first one of Y will be something like this. Okay, now this first one of Y, it will be 30 degrees from this one. So this is just 30 degrees. So 30 will be somewhere here. So it will be covering this part. Okay, 30 degrees, so it will cover this part. Okay, now this is first phase. Then second phase, it will be like this. I am taking this and this. Okay, now the second phase will be again 30 degrees from the second part, right? So this is the second part of this way. So delta will be 30 degrees from this. So this will be something filling these both ends. Okay, so this will be 30 degrees from the second one. So this is first one, this is second one. So this is 30 degrees. See, this is filling the middle parts. Okay, now we have the third one, which is this end of third and this of third, primary and secondary circuit, producing output voltage will be 30 degrees out of phase for the third phase. So third phase will be, this is first, this is second, and this is third. Okay, this out phase, it is 30 degrees, will be somewhere here. So I'm drawing like this only. Okay, it will be something like this. Now this third one here, if you see, first, this is second, this is third. So from third, 30 degrees out of third. So this has resulted in phase like this. So if I do on both sides, see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 pulse rectifier. So we have 12 pulses. That means in the same time we are getting 12 pulses. So 1 by 60 in 1 hertz we have 12 pulses are seen. So this is better when compared to the 6 pulse, right? So the ripple factor for 12 pulse rectifier theoretically is 3.5, whereas load ripple factor for 12 pulse rectifier is 5%. So in single phase system, which we have seen previously, we have 100% ripple factor is seen in single phase system. Now with 3 phase generators, there is almost constant potential is seen with the 3 phase generators. So that means this 3 phase circuits, either 6 pulse circuits or 12 pulse circuits, produce almost most efficient X-rays throughout the exposure. That is the major advantage. Whereas the second advantage of this three-phase generators is that there is higher tube ratings are seen even with shorter exposures. These three-phase generators are now built in such a way that the tube current up to 2000 milliamperes, they can produce a tube current of 2000 milliamperes. As a result, with the help of these three-phase generators, we can produce the X-rays with extreme short exposures and high repetitive rates, and these three-phase generators are excellent for using in angiography. So these are the different types of generators. Thank you.